The learning target for this lesson is that all students will be able to apply a couple properties of logarithms and then be able to simplify a logarithm. So let's back up here for a second. Remember how we had said earlier that a logarithm is basically just an exponent, which means all of our exponent rules apply. But there's only two exponent rules I want to really talk about. So if I gave you x squared times x to the fifth, you would remember that the base stays the same, and what we do is we add. So that becomes x to the seventh. So if I have two separate ones and I want to join them together for one simple answer, we call that condensing, because we're bringing it together. Now we could reverse it and I could say, how about if I gave you x to the 12th? Can you give me an example of two things that are multiplied together that will give me x to the 12th? So we would have x, and we just have to come up with two exponents, so when I add them together I get 12. So for example, I could do 5 and 7, or I could do 1 and 11. So either way I go, the rule still applies. So when you take a simple one and you make it longer, we call that expanding. Alright, now here's the other rule. What if I gave you x to the 15th over x to the 12th? Well, you know that even though it's a division problem, we don't really divide, we subtract. So then that will give me x to the third. And again, I could go the other way, still be okay. The biggest thing I need you to recognize is the two rules I want you to remember is that when we are actually multiplying exponent problems, we don't really multiply the exponent, we actually add the exponents together. So multiplication turns into addition. Okay, when we have a division problem with exponents, again, we don't really divide them. That division turns us into a subtraction problem because you're going to subtract the exponents. Okay, same rule is going to apply here. This is called the product property. Product means multiplication. So what you need to recognize, that there is a multiplication problem after the log base. So right here, there's your log base. So then afterwards, there's a multiplication problem. So what we're going to do is we are going to split this up, and we're going to add those answers. So if I had log base b of uv, it would become log base b of u, log base b of v. So we're going to take the u, or we're going to take the v, we're going to split them. They still both get that log base out in front of them, and then when we split them, we put a addition sign. So if you look at this example, here's log base 2, and after the log base, I want you to recognize that there's a multiplication problem. So we're going to split it into 9 and into x. And then what we're going to do is we're going to put the log base 2 in front of both. And then when it's a multiplication, we split it into addition. Okay, same thing over here. We're going to split the 3 and the 8 up. And we're going to go log base 2 with an addition sign. So that's what we call it when we want to expand out. And these will be multiple choice questions. Alright, let's go to the next property. Quotient. Quotient means division. So what you need to recognize is that after the log base b, there's a division problem. Now, if there's a division problem, what we're going to do is we're going to split it like this. Here's the u part, here's the v part. Here's the log base b and the log base b. But when we split it, we're going to use this subtraction symbol. For example, here's our first one. So here's log base 5. Right afterwards, you see this x over 8. So we're going to split it into the x and the 8. That log base 5 is going to be written in front of both. And then because this originally was a division, we're going to put a minus sign. Division turns into subtraction. Okay, the other one I have for you in this little section is this. So what we're going to do, we're going to notice here that there's a division. So I'm going to go y. But then notice down here that there's also a multiplication. So I have to split all three, the y, the 7, and the x. Okay. Now between the y and the 7, there's a division. So I'm going to turn that into a minus. But between the 7 and the x, it's an addition. And then what I need to do is go ahead and put that log base in front of all of my sections. So we talked about the two rules, addition and then the subtraction, and where they come from. This power property is probably the second most utilized property. I can get away with not telling you what to do, and you could still probably do it. So don't write this down in your notes, but I just want you to look. So if I gave you something like this, well, you could do it without me teaching you this. So what you would do is you would go loop-de-loop. So we would go 2 raised to the x is equal to 4 squared. So 2 to the x is equal to 4 squared is 16. And then you can find that missing exponent. 2 to what power is 16? It might take you a couple tries, or maybe not, but the answer would be 4. So technically, you don't have to know this property. However, it is going to make your life a lot easier for some problems. So what's going to happen here is we're going to go from something that looks like this into something that looks like this. So what happens is this exponent goes out in front and gets multiplied. So I've got the log base b of your u, and then I've got this n out in front. That means that the n that was in the exponent spot gets dragged out to the front. Okay, so let's take a look at one of my problems here. So I think the first one I gave you is log base 5 of x to the 7th. I need you to recognize that log base 5 of x is normal looking, but then you've got this exponent. So we're just going to bring that out in front. 7 times log base 5 of x, and that's it. That's all we can do. Alright, now the other one I gave you is log base 2, 32,768 to the 3rd. So what I'm going to do is I'm going to bring this out in front, and it's going to go 3 times log base 2 of 32,768. Now if all I asked you to do was to rewrite it, expand it out, we'd be done. But if I ask you to evaluate, you can find this answer. So what you would do right here is you would go loop-de-loop. So 2 to some exponent equals 32,768. And then when you get done doing all of that, we're going to just multiply it by 3. So take your calculators out and throw in something for that variable here and see if you can get this answer. It might take a few times, but I believe it will give you then 15, and then 15 times 3 will give you 45. So this property is going to be very powerful in the next lesson when we get into 6.6. Okay, so then this one right here, you know, we could do it the normal way, but let's just do it the easier way. Let's bring this 3 out in front. Okay, we're going to go ahead and do log base 2 of 4 by rewriting it. So 2 to some power equals 4. That will give us an answer of 2, and then we're going to times it by 3. So then our final answer is 6. And I don't think that that is in your printed notes. That's just an extra one. Alright, but let's look at the next one. So if I want you to expand, I want you to make it nice and long here. So what's going to happen is I'm going to separate the 5 from the x to the 7th. And then we have this y as well. And I'm going to put the ln in front of all the sections. Now what's happening between these two, these are being multiplied, so I'm going to put a plus sign. And then between 5x to the 7th and y, it's being divided, so that turns into a minus. Now you would think you're done. However, there's another rule. There's a power rule here. So you want to make sure that the 7 gets brought out in front. But we do not bring it way out here. We just bring it out in front of the section, the term that it's with. So this final answer should be ln 5 plus 7 ln x minus ln y. So that's what we call expanding. Now, some of your homework will give you the expanded form and want you to bring it back to this form. In that case, we call it condensing, like this problem. So I want you to recognize that there's 3 sections here, right? Okay, log 9, we're going to leave it as log 9. There's nothing we can really do with that right now. But then this looks weird. 3 log 2. That means that there's a number out front that was located in that exponent spot. So I need to put it back into that exponent spot. And then there's no number here, so I'm just going to rewrite that. Now, what I'm going to do is go ahead and do 2 to the 3rd. Okay, now we're going to bring it back together. So there's a plus sign here, so it does not mean we add these, it means we multiply those. So 9 times 8. And then there's a minus sign. Again, we don't minus them. That minus really means I turn it into division. So 9 times 8 divided by 3. Okay, that's going to give me 24. Now notice the word log, log, log. That means I only have to write log once. So the answer right now is log 24. Some people might write it like this because the base is 10, but that's not necessary. So you got to know how to do the expanding and then those condensing style problems. All right, now we're going to move into the last page of these notes, the change the base formula. So what we're going to do is we are going to trick the calculator into thinking that's a log base 10 problem. And that way we can type it in. So here's the deal. That's one of the reasons why I like math. You can manipulate the problems, which keeps the problem intact. It just makes it look different so you can work with it a little bit better. So what's going to happen here is if I ask you to do this problem right now and find the answer. Remember, the answer to a log is a missing exponent. So you would rewrite it as 4 to the x equals 9, and then you just do trial and error. Okay? This one you would say 7 to the x is equal to 3, and again, trial and error, guess and check. This one, though, you would have to go 2 to the x equals 4, and then you'd have to do 2 to the x equals 16, and then you add them together. Not a big deal. We all know that you can do those. But what we're going to do is we're going to trick it a little bit so the calculator can just type them all in at once. So what we're going to do is we're going to take any problem we want where the base is not 10. And then what we're going to do is we're just going to write a division problem and make the bases 10. And then what's going to happen is you have 2 numbers in the original problem. You've got the base number and then the non-base number. So the base number is going to go along the bottom here. And then the top number is going to be your non-base. And then when we go to type in the calculator, we don't need to write the base of 10. That 10, remember, is invisible. So we're just going to go ahead and write log of the non-base number and divide it by log of the base. Remember that base is always in the, like the thing about the basement or baseboards are always in the bottom. So just make sure you put the base, that little tiny number, in the bottom. So now if I want to type this in my calculator, I'm just going to type in log over log. Between these 2 numbers, the base is 4, so that goes on the bottom, and then that means the non-base goes up top. The only thing I want to caution you is to close the parenthesis. So go ahead and type that in right now. And then remember that we're going to round out to 3 decimal spots, the nearest thousands. Alright, and again, I could do trial and error instead. I probably would have eventually gotten there. Okay, let's type this one in. So we're going to go log divided by log. The numbers 7 and 3 have to go in the right spot. So it's 3 up top, 7 on the bottom. Now in this one, I could type in log 4 divided by log 2. And I don't even have to hit equals. I could just go right into plus. And then log 16 divided by log 2. Remember, the base goes in the bottom. And that will give you the answer of 6. And go ahead and pause the video and check it. But I wanted to show you can still do it the old way. Remember, the old way was just to rewrite it. So 2 to the what power is 4? 2. 2 to the what power is 16? 4. But then there's a plus sign between them, which will give you 6. But I also want to kind of show you on this one that you could recognize that you can condense the problem into one problem. So there's a plus sign. We're going to join the 4 and the 16 together, not by plussing them, but by multiplying them. And then we're going to go ahead and write log base 2. Now you can type in your calculator log 64 divided by log 2, and it will give you that same answer. So these properties are going to be very useful when we get into the very next lesson.